Hi, in this demo, we'll take a look at generative AI for advanced RAG systems in the context of AI governance. We'll pick up where we left off with the deployed large language model and H2O MLOps. We'll then look at the Enterprise H2O GPT UI, which is a foundational framework for advanced RAG systems. And then we'll look at the API for Enterprise H2O GPT. So machine learning engineers and developers can build their own custom tailored AI agents and applications. And then Eval Studio as an evaluation framework for large language models and generative AI. So here we have the H2O AI Cloud. At the top, we see Enterprise H2O GPT, H2O GPT, and Eval Studio. We'll take a look at Enterprise H2O GPT now. So if I go to the home here, it's broken out by chats, collections, and documents, right? So a collection could be a group of documents, it could be a single document, and we also have standalone chat sessions. So just to kind of walk you through creating a new collection and really interacting with your own data, you can create a new collection, add a description if you want, although we will add a description if you haven't using generative AI. You can upload documents from your computer. If you've deployed this on a on-premise or within your VPC type of situation, or even if it's air-gapped, you can import from local file systems. You can also import web pages. So we've got a built-in scraper. If you've got your local intranet that you want to scrape and process and use with generative AI, you can do that as well. And so you can just drag and drop and also toggle on and off the ability to, like I said before, automatically create short document summaries as well as sample questions to prompt you for conversing with your documents. So let's take a look at one that I've already got done. In this case, we'll take a look at a document related to the U.S. Veterans Affairs Office. You can see it's a fairly complicated report in that it's not just text data, it's images, tables, infographics, that sort of thing. So the process of going through and OCRing it in the most accurate way possible and parsing it and chunking it so you capture meaningful chunks. And then, of course, embedding those into vectors and storing that in a vector database is non-trivial. And we've been working on this for a long time, way before LLMs was a household phrase, I guess. So what we want to start doing is conversing with this, right? So let me go back to my collections. And so you might want to start conversing with it. Maybe a simple question is, what is this collection about? You can see we've got some example prompts there if you'd like to use. But what's going on right now? It's going out there using this data, using a large language model to provide some feedback back in the terms of a RAG system. So this will go on for a little bit. Maybe a good question to ask as another motivational example is, what does the USP STF stand for? So this is defined in the document. I've already read the document, so I know the ground truth answer, but it's kind of a good motivational example to see. Okay, it stands for the United States Preventive Service Task Force. That's great. But how did you find that information? So what we can do is point to exactly where in the document these chunks come from that are most relevant and where we found that information specifically. So you can see here we've got a similarity score at the bottom, and we're highlighting various parts of the documents, including, of course, abbreviations where that is defined. You can look at the PDF view, but of course you can also look at the raw text that's fed to the LLM context in chunk text. So let me scroll down. There's a few options here. You can also do upvoting and downvoting, right? So this is starting to get a human in the loop type of feedback mechanism for the AI to be learning a little bit more about how well it did, how it can improve, that sort of thing. We could see the actual prompt, the full prompt sent to the large language model, including the chunks, the system prompt, that sort of thing. We can also look at some usage stats. This is really important, especially when you're estimating various costs associated with the use case. In this case, we've got a 7-second response time for these settings, cost there in US dollars, but also specifically which model was used, the number of input and output tokens, and of course the settings, RAG in this case, right? So just some very specific information per chat you have here, but let's dive into some of the settings. So you can customize this quite a bit, right? And so I'm showing you this with a UI. We'll look at the API in just a second. But in the UI, you can provide a system prompt or a personality. In this case, right, we're offering a tip of $200 to answer the question correctly. We've seen that can improve performance, right? And we're specifying exactly what the system prompt's going to be. Now, back to my comment about starting with MLOps here. If we've deployed these models, we can directly reference them here within Enterprise H2O GPT. So of course, here in my demo environment, I've got, mixture of experts. I've got a lot of the H2O GPT models. We have our own foundational model that's been recently released. But of course, we can integrate with existing generative AI technologies. So if you're already using Anthropic, OpenAI, Google, right? So we can also integrate with existing models. Now, probably the more relevant piece here is the RAG settings. So we've got LLM only with no RAG. We've got a pretty vanilla RAG where we're going out there and doing cosine similarity search. We've got RAG plus with summary. This is for very large documents, right? Where we need to be able to summarize across a very large, document set, but trying to overcome the LLM's context window. Typically, that's very challenging. We've also got some advanced settings, hide RAG and hide RAG plus. Hide being hypothetical document embeddings. This is where you're first, taking not only the prompt, but also a first response from an LLM and embedding those to do RAG. The point there is you're going to require 2 LLM calls, whereas hide RAG plus might require 3 LLM calls. So as these kind of advanced RAG settings get more and more, advanced, we also have to consider costs associated with however many calls we're doing, right? So there's a bunch of different options here. You can also turn on self-reflection. Self-reflection is going to ask the model itself to determine whether it thought it had a good response or not. Go ahead and ask one more question, and I will turn the RAG settings on to something like, let's just go to hide RAG plus, and let's ask this question. So basically what's going to happen, it's going to show you LLM only, no RAG. So this hasn't looked at the data at all. It's obviously just making up stuff. This is the problem with a lot of LLMs. And then we're seeing the result of hide RAG, right? So in this case specifically, I asked nurse practitioners and facility leaders. And in this case, it's providing the correct responses that I want, the failures that I'm looking for. And it's going to keep going. But then when we do hide RAG plus with combined hide and RAG, what we should see here is that it's going to pretty much come back with the same response, but specifically and importantly, calling back a nurse practitioner 1's failures, nurse practitioner's 2 failures, and facility leaders' failures. So it's attributing correctly which failure is associated with which individual I'm asking about. And that's kind of the powerful results you can start getting with some advanced RAG settings here. So also, I'll quickly start looking at the APIs here. So you can get yourself an API key. We have tons of documentation on the Python client. It's as easy as pip install H2O GPTe. And of course, we've got some examples here of how to interact with the API, connecting, loading data in, ingesting, creating a chat session, that sort of thing. I think a better example of that might be if I flip over, let me show back in the AI Cloud, we also have a notebook interface. This is for interactive development, right, before you maybe get to a script. But if we click on that, here's an example notebook showing how to use the API. I can walk through real quick. So in this context, maybe we're trying to scrape the internet for a bunch of different government agencies, their public documents that are out there and information they provide. So it's pretty easy to connect. Just need the URL and that API key I showed before, get the client going, make that connection. And so here what I'm doing is I'm looping over each agency and I'm intelligently creating collections. So I'm creating about 7 different collections with a little bit of intelligence of what goes into those collections, right? And the reason why I'm doing that is because I don't necessarily want to search over all of the documents all at once. I kind of want to be able to intelligently search through specific agencies here. So I'm creating collections for each agency and I'm effectively uploading documents that I found on their websites. So I'll skip through all that. Some other kind of cool things with the API, you can get access to all the LLMs that are hosted there, right? So I've got a pretty big list here. For a given LLM, you could start conversing with it directly without any data there. So in this case, I'm asking it, what's your name? It's Llama, so it's telling me that it's Llama. But you can also get pretty granular here. So I can get individual chunks back for a given collection. So specifically, I can get each chunk in its text form from the vector database by simply iterating through and finding the ones that I want. So here's a few examples of that. Let me scroll through all of this. Another really good example, we have helper functions, really good APIs for common use cases and tasks. So for example, summarize content. We can point this to some predetermined chunks, maybe from a collection, maybe from multiple collections, maybe from just one document. we can specify both the pre-prompt summary and the prompt summary and an individual model, and then go out there and summarize it in a very, very efficient and advanced way. So here's an example of that summary. Given the chunks that I had previously found and identified, you can call out individual chunks to see what they are. It's subsettable. Another example might be to extract data. So we often find ourselves trying to do entity extraction using generative AI and large language models. Again, identify the chunks, identify the pre-prompt, and prompt to extract it. And so here you can see that I specifically went out there and extracted very specific information. I wanted to know for this agency whether there were any violations, and if there were, to return violations, the fine amount, and company. Those are the entities I'm trying to extract. And you can see here that it did a pretty good job. It went out there and told me the violation, actually the list of violations, the fine amounts, as well as the company associated with these chunks. So other things you can do, you can start encoding for retrieval. So if you have a simple query or you have a simple text string, you can take that text string and encode it using one of several embedding models that are in the backend there. So here you see I just took sanctions programs and I encoded that for retrieval. It's going to be a really big vector. That is the embedding for that text string. Scroll down, getting close to the end here. You can also simply interact with the backend. So if you're trying to build an application and understand which collections are available, upload collections, that sort of thing. Once you find a collection, right, you might be able to go out there and take that, again, that kind of retrieval query, sanctions programs, and max chunks. So we're going to be doing cosine similarity and neural search here based on that encoding, to go out there and find the most similar results. So here we found max chunks was set to 2. We found the 2 most quote-unquote similar chunks, and we get a lot of metadata along the ride for where exactly in that document these chunks exist. You can extract like the top K chunks of text. So whereas above there's a lot of metadata, you can also just kind of use list comprehension to iterate through that search result. Just pull out the text if you want, or you can pull out the cosine similarity scores from that as well. Now, you don't need to use neural search. You can also use lexical search. It's a little bit faster, a little more simple, right? So another example of that. And then last but not least, self-reflection, right? So with self-reflection, you're actually asking the model, try to go answer this prompt given this data, but how good did you do, right? You tell me how good you did. And so sometimes you can use some pretty powerful models to do that. In this case, we can use GPT-4 directly, right? But you can ask it to say, evaluate the quality of the response. Given the above context, here's the prompt and response. What is the quality of response? Answer with good or bad. You can, of course, get very specific. You can ask for a score from 1 to 5, for example. For simplicity's sake, I just asked to say good or bad. And so, of course, what I went out there and said, specifically which sanctions have been violated. I came back with a pretty good response, I thought, but it thinks it was a bad response, right? So, and then last but not least, you can use all these tools to either build an application, build an agent, or simply just output results, right? So one example might be if you're a bank, for example, maybe you're interested in those sorts of violations that I just showed, and just simply generating a compliance result for a given set of data and documents, maybe your internal documents, maybe public documents, to really quickly identify compliance results and generate some assets and collateral like this Word document here. Okay, so that's a really quick view of the UI and the API. And now if we take a look at Eval Studio. So that's great, everything I just showed, but understanding what's going to work is very difficult. It's much more complex than just, is this model better than another model? We've got many, many choices along for the ride here when we're building these generative AI agents. So for example, choice of embedding models, choice of chunking strategies, all those RAG settings we looked at, which model, of course, right? So it adds a little bit of complexity to understanding what's going to work well for a given use case. One of the challenges with these public leaderboards is that they use metrics that are very broad, right, across kind of general abilities, reasoning abilities, that sort of thing. But typically when you're building an AI agent or an application, you want it to be good at a particular task that either you're fine-tuning a model for or you're building the system with your data to do that. So Eval Studio is a piece of software that enables you to do that. You can go out there and create leaderboards, and a leaderboard consists of a connection to either a model or a RAG system. So in this case, maybe we'll just do a RAG system. The evaluator is the mathematical measure of performance, right? So in a RAG system, and we have ground truth answers, maybe answer correctness is the best way to do it. Some more advanced ones might be RAGus, where you're actually looking at various set of dimensions all put together. And then tests, this is really the important thing. This is a use case specific test, right? So it's a benchmark. So Ragus is one. We have a few examples. If I switch this to LLM, I think we'll see a few more examples here, right? So for example, a bank teller. There are known question and answers in exam to become a bank teller. You have the ground truth answer. You can test how well a model does at simply answering questions from the bank teller exam. And that bank teller exam is the use case specific evaluation framework you're building, right? And of course, you can pick a wide range of models to pick from when building your leaderboard. I guess if we stick with that bank teller exam, what does a completed leaderboard looks like? This is what it looks like. As an example, we've got a wide range of models that went out there and tried to evaluate. We could see for each model how many passes and failures, again, based on whatever that evaluation metric that we used was. And we can see the ranking. So obviously GPT 3.5 is doing pretty good. You can see a high-level summary for pass and failures, specific failures by prompt, so you can deep dive and understand exactly where things went wrong, that sort of thing. And there's also a report, a downloadable HTML report, or just a report where you can go in here and look at specifically for tokens presence, whatever that evaluator might be. In this case, it describes what it is. It describes kind of the mathematical approach towards measuring a success versus a failure, and kind of breaks down, results. In this case, just an LLM by pass and failure, as well as cost. Very important to understand at what point does a certain threshold of performance justify the cost, right? And so you can also break it down by time, right? So these are just sorted in particular ways, as well as kind of going in there and understanding for individual prompts, what was the failure and success rate? Where did this either agent, RAG system, or model simply not do a good job, right? So you get some pretty verbose information there. So there's a lot I skipped over there, to be completely honest with you. So we'll probably pause there, but that's a really quick look at building advanced RAG systems in the context of AI governance.